Hello my dear students, you are welcome. We are going to revise organic chemistry, paper 2, and our session on fuels, part 1. Let's start. Number 1. Petroleum is an important raw material that is separated into useful products. Which terms describe petroleum and the method used to separate it? Petroleum is a non-renewable resource extracted from Earth's crust. It contains a lot of chemicals found together in different percentages. Okay? They are not considered compound, so option A and B are incorrect. What about C and D? The answer either C or D. How we can separate these chemicals found in petroleum? What is meant by cracking? Cracking means separation, or we have long hydrocarbon, big organic compound, and we need to break down this compound into two or more substances. This is called cracking. But already we have a lot of chemicals and we need to separate them by certain method. What's the name of this method? It is not cracking. It is fraction distillation. Fraction distillation needs certain tower or column called fractionating column. This fractionating column, okay, where crude oil is heated before entering this column, and this method, this technique depends mainly on the difference in boiling points of each component, so the answer is D. Okay, is D. Description of petroleum: it's a mixture of a lot of chemicals, and we separate these chemicals by fractional distillation. Number 2. The industrial fractional distillation of petroleum is shown. Which process happens at Y? Y is found outside the fractionating column. What its purpose? What its job? It is needed as furnace to heat up crude oil. Why? For evaporation before entering fractional distillation tower. Okay, so the answer is D. It is needed for evaporation. Okay, what about burning, condensation, cracking? All the three options are incorrect. Why? Burning means combustion. Combustion, when a substance combine or burned in presence of oxygen, it releases energy and waste. Here, burning is not included in fractionating tower. Condensation process happens inside the fractionating tower, not outside, not in Y. We need condensation, okay, in the fractionating tower to separate each component according to its boiling point. So B is wrong. What about cracking? Cracking, as we said in question 1, breakdown of certain long or big organic compounds into two or more smaller substances. Okay, so the answer is D. Number 3. What is the name of fraction X? In order, refinery gas at the top. Okay, gasoline, second one. What X? Then kerosene, diesel oil, lubricating fraction, bitumen at the bottom of fractionating tower. Firstly, look also to this figure. In order, the refinery gas is called petroleum gas, okay, like gases. Then gasoline, then naphtha. So the answer, according to the choices, is C. The answer is C. Look, alcohol is wrong. Incorrect. Fuel oil is incorrect. Naphtha is right. Correct answer. Paraffin is incorrect. But why? Alcohol is not ingredients obtained by fraction distillation of petroleum. It is not hydrocarbon because it contains oxygen. Okay? Fuel oil, it lies or obtained from a point lower than X in fractionating tower. It is heavier than X. What about paraffin? Paraffin is the second name for kerosene. It lies below X also. So we have to memorize in order these ingredients when we make fractional distillation of crude oil. Okay, so the answer is C. Number 4. The fraction distillation of petroleum is shown. Which fraction is the least volatile? Least volatile. What is meant by volatility or volatile? Volatile means tendency of substance to vaporize, to become a vapor, like when we let perfume to change from liquid inside bottle into gas if left open. Okay, what would happen to perfume? Evaporate. This called volatile substance. Perfume is volatile. Water is also volatile, but lesser in degree. So, which fraction is the least volatile? Least means minimum of all ingredients that obtained by fractional distillation of petroleum. Which one? Look firstly. Bitumen. Bitumen, according to this figure, contains more than 70 carbon atoms. Okay, so it has higher molecular weight, so it is heavier. Okay, what about the relation between the MR, relative molecular mass, and or relative molecular weight, and the volatility degree? Look please, large molecules as the base of the tower. What its properties? High boiling point. It needs a lot of heat to reach its boiling point. It needs heating for higher temperature. Not very volatile. Okay, this least, it has least volatile degree. So the answer offshore A. Does not flow easily. Why? Because it tends to become solid, like asphalt, like bitumen, for example. Okay, as we are going downwards, as we going down, what about MR increases? What about boiling point increases? What about volatility decreases? It doesn't flow easily. Okay, does not ignite easily. Ignite means ignition or burn. Okay, or become burned or flamed. Okay, less flamed. What about the molecules at top of fractional distillation column? They are small molecules. They have low boiling point. They are gases at the top. Okay, very volatile, easily to evaporate easily, flows easily, ignites easily. Okay, so the relationship between number of carbon atoms in hydrocarbon and petroleum fragments, okay, and volatility. Volatility as lower boiling points means higher volatility. Look, as we're going on x-axis from 0 up to 20 up to 30, what would happen to volatility degree? Offshore it decreases. Okay, as MR increases, as carbon atoms increases, volatility degree decreases, inversely proportional. Okay, This ensure the answer is A. Okay, assure the answer is A. What about diesel oil? It is lighter than bitumen. It has higher volatility degree. Gasoline also has higher volatility degree because it is much lighter than diesel oil and bitumen. What about refinery gas? This is the highest volatility degree for refinery gases. Okay. Number 5. Which fraction of petroleum is not matched to its correct use? Bitumen and its use making roads. Yes. Here is a question about not matched. Bitumen is needed for making roads. Okay, is used for making roads or roofing surfaces. What about letter B? Gasoline, fuel for cars. Yes, it is used as fuel for our cars. Kerosene, fuel for ships. It is wrong. It is not used as fuel for ships. Instead, kerosene is used as fuel for jets, planes. Okay, also for heating gas stoves. What about naphtha? Naphtha is good and most important fraction of petroleum, is needed for chemical industries like pharmaceuticals, cosmetics, is used to make fertilizers, used as fuel and gasoline additives, used as many uses like in figure. Please don't memorize anything of this, just it is used in chemical industry. Okay, now what about the answer? The answer is C. Kerosene is not used for ships. Okay, is not used for ships, so it is not matched to its correct use. Okay. Number 6. Petroleum is separated into useful fractions by fraction distillation. Separation occurs in fractionating column like this one. Some properties of 3 of these fractions are shown. Fraction 1, 2, and 3. With its boiling point and their numbers of carbon atoms in each molecule. What's the relation between the number of carbon atoms, okay, and the boiling point? As we are going down through fractionating column, the number of carbon atom increases, okay, to reach bitumen with the highest number of carbon atoms. It reaches about 70 carbon atoms. At the top, the least number of carbon atoms. As we are going downwards, what would happen? Look, firstly, its boiling point. Here, large molecules with high boiling points. Okay, while compounds with less number of carbon atoms has low boiling points. So, letter A, fraction 1 has a higher boiling point range than fraction 2. Fraction 1 with 5 to 10 carbon atoms. Fraction 2 range from 16 up to 24 carbon atoms. So, as we are going down, what would happen to boiling point? It will increases. Here, letter E statements fraction 1 has a higher boiling point range than fraction 2. It's wrong. It's much lower than 320. Okay, this proportional carbon atoms is proportional to the boiling point. Increases carbon atoms means increases boiling point. So letter A is wrong. Okay, letter B. Fraction 2 is removed from a higher point in the fractionating tower than fraction 1. Also, as we are going downwards, what about fraction 2? Fraction 2 with higher or more carbon atoms it is removed in point lower than fraction 1. Here is removed from a higher is wrong. Higher point, higher position in the fractionating tower, it is wrong. Okay, what about letter C? Molecules in fraction 3, where is fraction 3? This one, have shorter chains than those in fraction 2. Sure, this right statement. Why? Look please, here the boiling point decreases from 320 to 120, so it also accompanied by decrease in number of carbon atoms lower than 16, maybe from 11 up to 15. So statement C is correct answer, is the correct answer. Okay, letter D, none of the fractions is liquid at room temperature. Look please, from 5 to 10 it is liquid because it is represented by gasoline, petrol, liquid at room temperature. At gas station it is liquid. Naphtha is liquid, kerosene is liquid. All of these components, okay, they are liquid. So the statement is wrong also. Okay. Number 7. The table shows the composition of 4 different types of petroleum. Okay, Arabian heavy, Arabian light, Iranian heavy, North Sea with percentage, and 4 fractions for each: gasoline, kerosene, diesel oil, fuel oil. Which type of petroleum is best for the motor vehicle industry? Which one is best? Vehicle means small cars and trucks or trains use diesel and gasoline. So look, which one is best of this 4 types of petroleums? The best one, which contains highest percentage of both components, gasoline and diesel oil. So we have to add for each type: Arabian heavy, 18 plus 18 equals 36, 21 plus 21 for Arabian light, okay, less than or more than Iranian heavy, 21 plus 20. What about North Sea? 23 plus 24 equal 47% of this petroleum contains gasoline and diesel, so it represents the highest concentration. Okay, highest concentrations of both gasoline and diesel oil found in North Sea petroleum. Okay, so the answer is D. Okay, now for number 8, bitumen is a substance obtained from the fractional distillation of petroleum. What are the boiling points and the sizes of molecules in bitumen? Bitumen here has more than 70 carbon atoms in its ingredients. Okay, what about boiling point? It's found at the bottom. It has high boiling points. What about the sizes of molecules? Large, very large. Okay, so the answer is A. Number 9. 4 fractions obtained from crude oil, petroleum are listed below. Which fraction is paired with a correct use? First fraction, bitumen. It's used making waxes. Is it correct? No. Wrong. Look, it is needed for road making and also roofing of surfaces, for roofing as insulator for water. Okay, what about letter B, diesel, fuel for aircraft? It's wrong. Okay, diesel is needed for trucks. Okay, trucks. and trains, not for aircraft. For aircraft we need kerosene or paraffin. Lubricating oil or lubricating for making roads, no, it is the usage of bitumen. What about letter D? Firstly, C, lubricating oil, okay, is needed for lubrication machines to prevent friction or reduce friction. What about paraffin? Paraffin is needed as fuel. Paraffin is the second name of kerosene. Kerosene or paraffin is used in two functions, in two usage. Fuel for oil stoves like this one, okay, and also for aircraft, okay, or planes. Okay, so the answer is D. Number 10. Diesel, petrol, and bitumen are all what? Letter A, fuels. B, hydrocarbons. C, lubricants. D, waxes. Look firstly to this figure. What about diesel? Diesel is used as fuel for trains and trucks. Okay? This diesel. Petrol is used as fuel for petrol. I mean gasoline is used for car. Petrol for vehicles, car. But bitumen is needed for road making and roofing. So letter A is wrong. Letter B is the answer. Diesel, petrol, and bitumen are all hydrocarbons, only containing carbon and hydrogen. So the answer is B. What about letter C? Lubricants, diesel, petrol, and bitumen, none of them act as lubricant or even act as waxes. So the answer is B. Here also look at boiling point 20 Celsius. Okay, petrol for example here. As we are going downwards, what would happen to boiling point? Increases gradually, increases in this direction. So the smallest hydrocarbon molecules, it means it contains less number of carbon atoms in black circles like this compounds. Okay, as we are going down, what would happen to number of carbon atoms or chain of the carbon atoms? Increases in length. Okay, so the answer is A. Number 12. The table shows some fractions that are obtained from petroleum by fractional distillation together with some of their uses. Okay, 1, 2, and 3. And their uses: making chemicals, jet fuel. Number 3, fuel for ships. Which row correctly identifies fractions 1, 2, and 3? For fraction 1, making chemicals, which fractions used for making chemicals? Sure, naphtha. So the answer is D. What about number 2, jet fuel, kerosene? Yes, kerosene or paraffin. What about 3, fuel for ships? Fuel oil for ships. So the answer is D. Okay. Number 14. Number 13. Which substance has a main constituent that contains only one carbon atom per molecule? Okay, main constituent: bitumen, gasoline, natural gas, petroleum. Look at the fractions of petroleum. Fraction petroleum gas, refinery gas, range of carbon atoms from 1 up to 4. Petrol or gasoline from 5 up to 10, and the other ranges. Okay, to reach bitumen with more than 70 carbon atoms per molecule. Look at the fractionating column. What about bitumen? More than 70. What about refinery gas? Range from C1 up to C4. So, guess, we choose refinery gases that contain from carbon atom one carbon atom up to 4 carbon atoms. This is the least number. What about the choices? Bitumen has more than 70. So bitumen is incorrect. Gasoline, here in this part, gasoline from 5 up to 10. So it is also wrong. What about natural gas? Natural gas, like this cylinder containing natural gas, the main constituents of natural gas is methane gas. What about molecule of methane gas? One molecule of methane gas containing only one carbon atom. Only one carbon atom. So the answer is C. Look also to this last figure. For natural gas, the green part of this pie represented by methane. It represented or corresponds to 94%, while the other 6% may ethane reach 5%, other like propane and butane, the other 1%. So the main constituent that contains only one carbon atom per molecule is natural gas. Why? Because the main constituent is methane, CH4. The answer is C. Okay? The other answers A, B, and D are incorrect. Now, for which pair of molecules are hydrocarbons? All petroleum components are hydrocarbons. What is meant by hydrocarbons? Compounds that containing hydrogen and carbon only. No oxygen, no other elements. Only carbon and hydrogen. Okay? In each compound. So, for first choice, ethane and ethanol. This ethane, C2H6, entirely hydrocarbon, containing 2 carbon atoms and 6 hydrogen. What about alcohol, ethanol, containing O, oxygen? So it is not a hydrocarbon. So letter A is incorrect. What about second choice, letter B, ethane and ethene? Both are hydrocarbons, no other elements, only 2 elements, carbon and hydrogen. So the answer is B. Let's check C and D. Ethanoic acid, okay, CH3, COOH, OO. Oxygen is involved in structure, so it is not hydrocarbon. What about ethene? Okay, hydrocarbon. So letter C is wrong due to ethanoic acid containing oxygen. He asked about hydrocarbons that contain carbon and hydrogen only. Okay, what about letter D? Ethanol, CH3, CH2OH, or C2H5OH, O present, so it is not hydrocarbon. Okay, what about ethanoic acid, also containing oxygen, so it is not hydrocarbon. So the answer is B. Thanks for watching. See you in more and more videos, inshallah. Bye bye.